Hey guys, Nick Pebler here with the fifth video presentation. This one's for 4.2, number 10. So we're given a problem here, and we have to solve with Laplace, and we're given an initial value that we need to solve for. So up here, this is what we're given. It's x double prime plus 3x prime plus 2x equals t, with the function x of 0 equal to 0 and function of x prime of 0 equal to 2. I guess, sorry, I should kind of reword that. This is function x of time. So when this is equal, when time is equal to 0, then it gets plugged into this x, this function x, if that makes sense. So right here, I just have a little background on chapter 4, applying the definition of Laplace. So just kind of goes into how you kind of set up and get working with these problems. And it's basically just saying what we're looking at is an integral with this. This is what we're given in the formula. And so due to the bounds, this is 0 to infinity, it's an improper integral. So we can take the limit from a to b of this function. So it's just a little conceptual side, more connected right into the beginning of 4.1, and obviously we're working with 4.2, but sometimes it's nice to just look over the conceptual side again, kind of understand what we're working with here. So to build on that, we're given this new form for 4.2 of ax prime t plus bx prime, ax double prime t plus bx prime t plus cxt equals function t. And that's what we have up here. We're given this x double prime plus 3x prime plus 2x equals t with these initial conditions. So background of this problem's over. Now we can kind of start working on it. So we're solving with the initial values. So we use our formula that we're given in this chapter, and we begin solving out using what we're given. So we want to find the x prime and x double prime values in regards to Laplace. So we solve out just plugging into our formulas here, and we get, by doing this, s, which times Laplace x of t minus x of 0, this initial condition 0, and we're given s and then x of s minus 0. So x prime is just this s x of s, and this will make a little more sense as we continue going on. Same here with double prime. Now we're solving this again. So s squared, because now we're dealing with double prime, Laplace minus s x of 0 minus x prime of 0, another initial condition here of 2. And this is obviously going to just go to 0. So we're left with s squared x of s minus 2. Excuse me. So we have this x prime and this x double prime. So now that we have these, we can plug it back into our original given. So we have s squared x s minus 2. This gets plugged in here, just right back into the original, because we had x double prime plus 3x prime. So we look up here, just this sx of s multiplied by 3, then plus 2x of s, because that's just x. So this x of s is treating it like the function that we're given up here with the chapter, where we have t, so it has to be a function. We're just using s. So we set that all equal to 1 over s squared. That's our t value, essentially. So simplifying this down a little bit, s squared plus 3s plus 2, just that's coming from distribution. All times x of s equals 1 over s squared. And we can simplify this down and get s plus 1 times s plus 2 by FOIL. And then with this adding 2 to the other side. So we get x of s is equal to 1 plus 2s squared over s squared times s plus 1 times s plus 2. So now that we have this, we have to figure out what's going on with these s values in order to solve this problem. So we have to use partial fractions to clean this up a little bit. So we take all of these individual pieces that we've kind of split apart. We can assign 4 different variables to these. So we have a over s plus b over s squared, and then plus c over s plus 1, and plus d over s plus 2. And then it gets a little messy here, but to get this all on one side, multiply the variables by each other, essentially, or what's on the denominator. And we end up getting a s times s plus 1 times s plus 2 plus b times s plus 1 times s plus 2 plus cs squared, excuse me, s plus 2 plus ds squared s plus 1. And all of this is equal to what was the numerator in this partial, which is 1 plus 2s squared. Now that we have this, we can start plugging in our s values in order to get our constants. So we start with 0, go down from there. So b equals negative. B equals 1/2 or 0.5 when s is equal to 0. Then we go -1. C is equal to 3. Go down again, -2. D is equal to -9/4. Now that we have these three, we can look back at our original, and now we can solve for a with what we're given, or what we've solved, excuse me. So we get, it's a plus c minus, or not minus d, plus d, and this is how we're going to solve for our a. So it's simple. I mean, just move, or add these together, and then move it to the other side, which is set to 0, and we get a equals -3/4. Now that we have all of our variables solved for, we can plug back into our x of s, which we had. I'm sorry, I thought I wrote it on this page. Let's see. Yep, right here. Or 1 plus 2s squared. Oh, I did write it here. Sorry. It is currently 1:30 in the morning, and I'm trying to get everything done before we go on our 4th of July trip. So here's our x of s, and we're going to plug in our variables that we just solved for. So we have -3/4 over, or -3/4s plus 1/2s squared plus 3/s plus 1 minus 9/4 times s plus 2. So this is essentially the Laplace that we've done here, and that's what x of s has been talking about this whole time. So with this, now we can split up our s values and get ourselves some values. So when we have 1/s, it's equal to 1. When we have 1/s squared, it's equal to t. And then 1/s minus a, we get e to the at. Now with this, then we can simplify down even more to our function and get x of t equals negative 3/4 plus 1/2 t plus 3e to the negative t minus 9/4 e to the negative 2t. And then distribute this out a little bit, clean it up. We get x of t equals 1/4 times 2t minus 3 plus 12e to the negative t minus 9e to the negative 2t.